So the exam question says, compare and explain the reactivity trend of the alkali metals and the halogens. So let's first of all look at the important words in this sentence. Compare means what's the same or different. Now explain is saying why something is that way or why something has happened. When questions talk about the reactivity trend, it's how the reactivity changes going down the group. The alkali metals, you need a bit of knowledge there, remembering that the alkali metals are group 1 of the periodic table, and similarly the halogens are group 7. So this question is saying, how do the halogens and the alkali metals change as you go down the group? Is the reactivity getting more reactive or less reactive? Is it the same for both groups? And then we need to say why that might be the case. If we first take the compare part of the question, you need to remember that as you go down group 1, the alkali metals become more reactive. And if you didn't know that, I'll put a link up here now to a previous video showing you practically how they get more reactive. If we compare that to group 7, it's the opposite trend. As we go down group 7, the halogens become less reactive. So we can now start actually answering the question, and we would say that alkali metals get more reactive as you go down the group, whereas the halogens get less reactive as you go down the group. Now we need to explain why the alkali metals get more reactive going down the group, and it always comes back to their electronic structures. So at this point you'd find a spare piece of paper within your exam paper, maybe the bottom of the page, and quickly sketch out a couple of electronic structures. I've done lithium and sodium here, the top two in group 1. And we can see as you're going down the group, the atoms are getting larger. They both need to lose one electron from the outer shell to become stable with a full outer shell. And we can see the outer electron of sodium is further from the nucleus, and there's also more shielding from the inner shells. So it will be easier for sodium to lose that outer electron. So we'll add that to our exam question answer, and we'll say this is because as you go down group 1, the atoms of the alkali metals get bigger. So it's easier to lose the outer electron as it's further from the nucleus, and there is more shielding from the inner shells, so there is less attraction between the nucleus and the outer electron. Whereas with the halogens, and then we need to consider the halogens. So like before, I'll quickly sketch out the electronic structures of the first two in the group, and again we can see as we go down the halogens group 7, the atoms are getting larger, but this time they need to gain one electron to get a full outer shell and be stable. So as you go down the group, because that extra electron is going to be further from the nucleus and there's extra shielding from the inner shells, it becomes more difficult this time to gain an electron, and that's why they're becoming less reactive. If we add that to our answer, we would say, whereas with the halogens, as you go down the group, the atoms get larger, so it becomes more difficult to gain an electron, because the electron is further from the nucleus and there is more shielding by the inner shells, so there is less attraction between the nucleus and the extra electron. So you can see we've gone into a lot of detail there, but it is a 6-mark question. If you found it useful, don't forget to give it a like and make sure you subscribe so you don't miss out on future videos. Thank you for watching.